instructions. Right? Each one is actually an instruction. So when I say x is equals to 10, you are actually telling the computer, okay, remember 10. You are telling the computer, yeah, remember 10. And then you are telling the computer, remember 5. Right? You are telling computer, remember 5. And then finally you are telling add x and y. So that's the third instruction that you are giving. And then finally you are saying display the results in the monitor. So what we actually have done here is we have created set of instruction for the computer to execute. So so each one, right? Each one is actually called, each line is actually called a statement, yeah, a statement. And we put the statements group together, and then we call this as program, yeah, as program. Right? We then after we put that into one file, and we call that as program. The guy who does programming is a process of developing such program. Yeah, programming is a process of developing such program. The guy who does this programming is called programmer. Yeah, we call him as programmer. So program, programming, and programmer. Right? So technically we are giving instruction to the computer, and then the computer execute this instruction. So yeah, we already know, after going through the schools for so many years, okay, now only we can speak a little bit in English, and we can understand a little bit about this instruction, right? But computer never go to school and he never learn anything. So how does the computer understand this instructions, right? And how does he actually execute them? Guys, Kara, right? That's quite challenging, right? So the guy who never goes to school, so that means he actually don't know anything. He actually don't know numbers. He don't know alphabets. That means he actually don't know A, B, C, D. He don't know 1, 2, 3. So he actually knows nothing. But he can execute your program, and he can actually produce an output. So how does this actually works? So in a computer, now we have a part called CPU, right? And this guy is a central processing unit. We call it as a processor. And he is the one actually execute these statements. Yeah, he is the one who actually execute this statement. But how does he know what to do? Right? Because he don't know what is x, he don't know what is equal, he don't know what is 10, but he's supposed to remember this. Okay, so guys, what happens is this program is actually passed to another component, right? And we call that as compiler or interpreter. Compiler or interpreter. And this compiler or interpreter actually convert this data, this statement, yeah, this one statement, right? This one statement, he convert this statement into something called binary. Yeah? The instruction is converted into something called executable binary. So what is that binary? Guys, when you say the output of this compiler or interpreter is actually a binary statement, statement. Right? This compiler will convert it into a binary statement, which the computer actually understands. All right? Which the computer actually understands. So this binary statement, so how it actually converts it into a binary statement. What is this binary statement? Of course, we need to understand that. So because since we go to school, we know what is 10, right? The teacher actually teaches us, and we learn along the way. After a long time, we actually manage to learn. But guys, how the computer actually does this? The computer actually has something called RAM, memory. Memory, we call that as memory. And guys, in memory, so this you can say it as a RAM, RAM. And what do we actually have in a RAM, guys? We actually have lots and lots of switches, right? So we have arrays of switches, like this. This is the count. I will explain, how many and all those things. I will explain that in a short while. Yeah, but anyway, so this is array of switches. All right. Guys, is it okay?
Okay, sir.
All right. Okay. So we have arrays of switches. All right. And this switch is on and off. Yeah, is on and off. So meaning, if it is off, then it is actually 0. If it is on, then it is actually 1. So that means, this is what we call it as binary. Yeah, this is what we call it as a binary. All right. This is what we call it as binary. Hang on, yeah. Okay. So this is what we call it as a binary. So now the computer actually translate this information into a binary. So for example, let's say a 10, 10. If you want to convert it into a binary, then guys, what we normally do is we take the 10 and then we divide the 10 by 2, by 2. We divide it by 2 because 10, computer do not understand 10, because he never go to school, right? So we will actually take this 10 and we will divide it by 2. Then guys, you get 5 2s are 10, and your reminder is actually 0. That's the reminder, So this is the quotient. This is the reminder. And then now again, I will divide it by 2. So 2 2s are 4. So 2 2s are 4. But the reminder is 1, The reminder is 1. So now again, I will divide it by 2. So 1 2s are 2, and the reminder is actually 0. So guys, now we will write it in this direction. So you will write it like this. So when you do this, what you actually get is you get 1 0 1 0. Right? So the binary value for 10 is the binary value for 10 is 10 10. So when we say 1 0, right? When we say 1 0 1 0, so that means what it means is in the first cell, right? The current is there. In the first cell we have the current. So when you have the current, so that means here I got current, and here I don't have current, and here I got current. And finally, I don't have current. So that means now this 4 switch, yeah, you can imagine it's like a switch, our on-off switch at home, right? So you can on the fan, off the fan, that switch, yeah, that switch. So I'm talking about that switch, yeah. So basically, so now the first switch is on, the second switch is off, third switch is on, and the fourth switch is again off. So that 10 is stored in a RAM, something like this. So the next time when you actually retrieve, you will get it as binary, and you have to convert that binary into a number, right? So 0, and then we will multiply this with the 2 to the power of zeros, yeah? 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So that means I will take this 0 and I will multiply this with 2 to the power of 0, right? 2 to the power of 0. Similarly, I will take the next digit, which is actually 1, and I will multiply that with a 2 to the power of 1, yeah? 2 to the power of 1. So 2 to the power of 1, right? And again, the next one is a 0. So which I will multiply it with a 2 to the power of 2, yeah? 2 to the power of 2. Right? 2 to the power of 2. And then the third one is 2 to the power of 3, yeah? So of course, obviously, when you multiply it with a 0, so we know you end up with a 0. So the next one will be 1 multiplied with 2 to the power of 3. So guys, look at it. You got 8, 8 plus 2, 10 already. Right? So the binary is converted to a decimal, yeah? Binary is actually converted to a decimal. Look at this, yeah? So because you this one is a 0 already, this one is a 0, this one is also 0, so you have only 1 here. So 2 to the power of 1 is actually 2. And then here, 2 to the power of 3, yeah? 2 to the power of 3. That means a 2 multiplied with the 2, 4, 4 multiplied with the 2, 8, yeah? So you got 8. So in total, it's 10. So that's now we got back the 10, yeah? We got back the 10. So this is how computer actually does everything. So all the computer actually knows is the binary values, 1, 0, 0, 1. Guys, only that. He knows nothing. Yes, understand, right? He actually knows nothing. All he knows is just the binary. And this computer is actually doing so many things, so many unimaginable things. Right? And this guy actually, he never learned anything, guys, understood, right? So now we are training him, we are making him to learn, we are doing many things, right? And now we have AI, artificial, guys, everything is just based on this ones and zeros, yeah? So the computer know nothing but 1 and 0. So this is what I mean by binary statement. So we will write the program, we will actually write the program in a language, computer language, in a computer language, but still, still the computer language is more readable, and this compiler will convert that into a binary statement like this so that the processor can execute them. So that means, like any document, Word document, or any photos that you keep in the computer, in the hard disk, in the RAM, they all are kept in ones and zeros, right? They all are kept in ones and zeros. So computer means, guys, everything is ones and zeros. So why I'm actually saying this, guys, this is how, the computer is actually, understanding your instruction, and he is executing your instruction, and he's producing the result that you actually looking for, guys. Understood, right? So it is not, this is how, guys, this is how the entire computer is actually working. So the super power computers, guys, like they actually does this processing very fast. So we are not able to really see them, how fast it's actually doing things. But anyway, guys, so this is how it is. Yeah, this is how it is. And we have a RAM and we have the processor. And of course, we also have another one, which is called hard disk. And hard disk is something where you keep things permanently, right? You keep things permanently. But, this is for processing. Yeah, for processing, we actually use the RAM. So, okay, roughly we got an idea. Yeah, we got an idea how computer actually executes. So now we understand what is program. Yeah, what is program? So program is actually nothing but set of instructions. Yeah, set of instructions. Okay, which we are giving it to the computer, and then the computer execute that instructions, and it produced the necessary output. Yeah, it produced the necessary output. All right. So now the next question. So that means, guys, understand. Where can we see this kind of a calculation? Yes, it's very easy actually. I did it by hand, but it is actually very easy. If you go to the calculator, and then if you go to programmer, guys, if you are able to see, yeah, yes, you can actually go to your calculator in your computer, and then you can this programmer, and then you see, the moment you choose programmer, you can actually see 4 different number systems. The number system that we always use, this decimal number system, guys, decimal number system. The one that I talked to you about just now is binary system. This is the binary system. So in the decimal system, if you have 10, then the binary value is 1010. Similarly, guys, we also have hexadecimal system. We also have octal system. I think, never mind, I think I don't want to talk about that today. But anyway, guys, there are other number systems. But the computer don't know any number system. All he knows is just the binary. Right? Okay. So, everything, every single instructions that we write, it actually gets converted, every single instruction. Yeah, instruction, not just the data. Just now I just demo the data, yeah, the data part. Yeah, the 10. I showed you how the 10 is converted into a binary and stored in the RAM. But it's not just the data. It is also, the instruction, the entire instruction is converted into binary, so that the computer understands what needs to be done, and it executes and produce the output. Right? Okay. So now, yeah, Jagan, how did you actually come up with these lines, piece of lines, right? Okay, guys, we all here because now we want to become a programmer, right? We all want to become a programmer. Yeah, we all want to become a programmer. Guys, there are many people out there, even IT people. who are studying IT for so many years or 3 years, computer science, and end up they are saying, they are not able to do programming. That's correct, right? There are a lot of IT graduates who complain that they are not able to do programming. Okay, guys, let me talk about programming. So programming, program. So to create a program, you need actually two things. You need to be very good with two things, One, you have to choose a language which the computer understands. So that means, remember just now I said, you have to write the instruction and you have to pass it to the compiler. So when you pass it to the compiler will convert this into a binary and then it gets executed. Can I simply write something here and expect the compiler to compile it into binary statement? Guys, no, definitely cannot. It has to follow some syntax. It actually has to follow some rules. The statement must be like this. There are rules. There are rules, and people must follow the rules, right? So first step is actually you choose a programming language, right? So the first thing, in order to become a programmer and in order for you to write a program, give it to the computer and ask the computer to execute it, first you must choose a language. And then you must master the language. Master the language. Right? So this is the first task here. This is the first task. So you must choose a programming language. Right? And then you must master the language. So this is task number 1. And many of them actually able to succeed this. They actually know how to do, they know the language. Okay, they understand the language. They understand the language. Yeah? They understand. So if I tell them, can you please create a decision making statement, and then they will know, okay, I have to put if statement. They actually know how to create this program. So they actually know, because they have the knowledge on the language. So using that, they will be able to create something like this. But most of them actually fail where, they fail on something called logic. Right? And not many people can come up with their own logic to solve a problem. Right? Most of them, are not able to come up with the logic, with the logic. So is it something like a special thing that, only certain people has it, and others, very difficult for them to get it, That's no, not really. There's no such thing, guys. There is no such thing. So, hey, I can't get the logic, guys. That means you did not try enough. So that is the observation, guys. So it's not like you cannot do programming. Only certain people can do programming, guys. No, there's no such thing. Everybody can do programming, but you have not given enough. You have not put enough effort on it. Somebody, has put enough effort, right? They already put enough effort, and they managed to get, build the knowledge on logic, on logic. So all you need to do is, guys, you need to keep trying, and then you will be able to, find the logic. Okay, let me explain with a simple example. Simple example. Okay, so let's say I give you a problem. I give you a problem. Let's say I give you a problem. The problem is find whether the given number is even or odd. Find whether the given number is even or odd. Guys, so the given number is 5. So guys, what you're supposed to do is supposed to find whether that the 5 is even number or odd number. Yeah, I can hear many people are saying, it's an odd number. So how did you know that it is an odd number? Because guys, we've been, going to the school for very long. And in a school, they actually teach us, you have to take that 5 and you must divide it by 2. And if the remainder is 1, then you have to say this is odd number. Then you have to say print odd number. Right? Guys, odd, you have to take the number. Say let's say the given number is a 6. Again, you will take the given number and you will divide it by 2. Then you get 0 here. Then you have to say print even. So it depends on the remainder. It depends on the remainder. So guys, how you manage to find whether the given number is even or odd? Okay, so we take the number, we divide it by 2, and then we get 1, guys. And this is what we call it as logic. All right? This is what we call it as logic. So this is what we call it as problem. So first you must understand the problem, right? After you understand the problem, okay, even number, odd number, you actually have to search. You have to see, how to do this, right? How to do this. So once you know that, you actually can come up with the program. So you know what to do. So guys, here we have 2 things. Yeah, we have 2 things. So to master the language, after you master the language, what you know is how to do. Guys, understand, right? So after you master the language, master the programming language, you will know how to do. But guys, you still don't know what to do. So the logic is actually, if you manage to answer the question, what to do, then guys, you break the logic already. So you got the logic already. So that means, you know what to do. Guys, if you know what to do, if you actually know what to do, and because you master the language, now you actually know how to do. So guys, then you actually, if you have both already, then you actually can solve the problem already. Guys, understand, right? Okay, so many of us actually fail. We actually know what to do. Okay, I'm going to give you one more example. Again, we know what to do. Divided by 2 equals to 1. That's what to do. What we know already. Yes. This is a very simple problem. Now I'm going to give you another problem, guys. Reverse the given number. Reverse the given number. Yes, so this is another problem. Yeah, another problem. So given number. So given number is equals to 98765. And what you're supposed to do, guys? So by end of the program, you're supposed to print the result is equals to 5, 6, 7, 8, 9. All right. So this is the output that I actually want. Because guys, I said, reverse the given number. Right? So mathematically, guys, I want you to solve this mathematically, guys. Even if you are a programmer, don't come back and tell me that, in Python, you can do like this. In Python, you can do like that, guys. Of course, the one all we know, right? But now, guys, I want you to solve this problem mathematically, right? Okay, so how do we actually do that, guys? It's not about how, what to do next. So now we need to know what to do next. And what to do next, what to do next, what to do next until you get this result. Okay, right? And that is what we call it as what to do. So now do we know what to do? Unfortunately, no, we don't know. But guys, you see, when I actually ask you to reverse the number 98765, when I wrote this, I know almost everybody in the room say it as 56789. Guys, correct, right? You guys say it as 56789. Is any one of us say 56,789? No, guys, never, right? Nobody actually might thought it like that. Guys, correct, right? Might say it like that. Nobody may have said it, I don't know, guys, if any one of you managed to do that, guys, then I don't know what to say, guys. But what I'm saying is definitely, you immediately said the answer as 5, 6, 7, 8, 9. That's correct, right? So that means what you did, you took the last digit and you say it first. And then you took the second last digit and fourth say it and fifth, So all you did is pull out the last digit. Yeah, all you did is pull out the last digit. So guys, that is what you did. Yeah, that is what exactly you did. You pull out the last digit. How did you actually pull out the last digit? Yeah, how can we actually pull out the last digit mathematically? Right, the last digit. Guys, remember whenever we divide, right, with some number, by doing division, we can definitely get the last digit. So guys, what you actually can do, you actually can take the given number and divide it by 10. So when you actually divide it by 10, right, guys, what is the quotient and what is the remainder? So the quotient will be 9876. And the remainder is 5. Guys, look at it. You managed to pull out the 5. Of course, that is what we want, right? Guys, so we managed to pull out the 5. So remember, when I actually asked you to reverse the number, your brain immediately says 5 without thinking. So that's how your brain is able to say it, guys. Visually he's seeing it. Understood? But anyway, guys, mathematically, all you need to do is divide it by 10, then you get the last digit. Right? Okay, now what is the next step that I have to do? Guys, I have to take this 9876 and divide it by 10 again. right? So guys, now I have to take this 9876 and I have to divide it by 10 again. I already have 5, yeah? I already have 5, right? I already have 5. The first step, we took this 98765 and we divide it by 10. Right, we divide it by 10 and then we got the remainder. Yeah, we got the remainder and also the quotient. So now what I'm saying, you have to take that the quotient and continue your division operation. You have to take the quotient. Yeah, so we take the quotient and continue the division operation. Right. So guys, now what you get? You get 987 as the quotient. So you get 987 as the quotient. And then the remainder, again, guys, you end up with 6. Yeah, you end up with the 6. Right? So guys, now we got 5 and we got 6. We got 5 and we got 6. So what is the next step that we have to do? Guys, you have to say 5, 6. Right? You actually have to say 5, 6. So the 5 should go in front and then the 6 should go next. All right. So guys, in order to do that, what you're supposed to do, guys, you have to take the 5 and you have to multiply the 5 with the 10 and then you have to add 6. So guys, now what you get? You get 56 already. You get 56 already. Yeah, you get 56 already. So what is the next step? Again, guys, you actually have to take this 987. You have to take the 987 and divide it by 10. Again, guys, correct, right? You have to continue. So 987 and you have to divide it by 10. Guys, what do you get? You get 98. And the remainder will be 7. So guys, you already have 56. So you have to multiply the 56 with the 10. Right? So you will take the 56 and you will multiply this with the 10 and you will plus the 7. So guys, what do you get? You get 5, 6, 7. Guys, can you guys see the number is getting reversed? Right? The number starts getting reversed. 5, 6, 7. So what is the quotient now? Guys, the quotient left out as 98. So I will take the 98 divided by 10. So the quotient will be, guys, the quotient will be 9. Will be 9. Okay, and the remainder will be 8. The remainder will be 8. Right? So quotient is 9, remainder is 8. Guys, you know what to do already, right? So you will take the 5, 6, 7. You will take the 5, 6, 7, multiply with the 10, and then you will add the 8. So you get 5, 6, 7, 8. Right? You get 5, 6, 7, 8. So what is left behind now, guys? We are left with just 9, yeah? Just 9. So you will take that 9 and divide it by 10. Of course, guys, you cannot divide, yeah? So we are not talking about decimal values here. So I cannot divide. So guys, the quotient is actually 0 because no more. I cannot divide it anymore. And the remainder is 9. Right? Guys, the moment the quotient becomes 0, we can stop it already. We actually can stop it already. Right? We can stop this process because the quotient becomes 0 already. So nothing for us to divide anymore. So we can stop this process. Yeah, we can actually stop this process. So now, guys, now the last step, which is actually nothing but 5, 6, 7, 8 multiply with the 10 plus 9, which gives you 5, 6, 7, 8, 9. Guys, understood, right? That's it. Guys, look at this. You managed to reverse the given number. So you got 5, 6, 7, 8, 9, which is the result. Which is the result. Guys, if you know what to do, you can. So this is what to do, guys, this is entirely what to do. I'm not talking about how to do in Python. Guys, understand, right? We are just talking about what to do next so that we can slowly reverse the given number. Right? So we are not reversing it immediately. We are reversing it slowly, step by step by step. And finally, guys, we managed to get the reversed number. Correct, right? So this is what I mean by what to do next. Right? So if you know what to do next, and if you have mastery in Python, then you can quickly translate this logic into a program, and then you can pass it to the computer, and you can ask the computer to reverse any given number. Right? So yes, you may technically you teach the computer already how to reverse any given number. So of course our friend will be able to reverse large numbers, quickly, and he can produce the output, the computer. So guys, this is what I mean by logic. Guys, initially I talk about logic with even number, odd number, and you find it like, hey, there is no complication there. But guys, now when we actually try to reverse the given number using mathematical formula, guys, you feel like, hey, so complicated, lah. That's correct, right? Correct, right? So how Jagan, you came up with that logic that we have to divide it by 10, and then you have to take the remainder. How Jagan, you came up with the logic, guys? Yeah, I've been doing programming for 30 years, so definitely I know this. As understood, right? 30 plus years I've been doing programming. So of course, I come across many problem in my life, and I keep solving one after another. So I build my logic already. So whenever I want to pull out a digit from a number, pull out just one digit from a number, I know we have to divide it by 10, or we have to divide it by 100, or we have to divide it by 1,000, and then we know already, guys. So how did I actually know this? Did anybody teach me? No, guys. I keep doing this problem solving again and again and again and again. And now, guys, I got this logic, right? Something called, developing logic, to solve the problem, developing logic to solve that problem. Yeah. So the problem is given and you're supposed to solve that problem. So to solve that problem, you need to be mastery. You need to have a mastery in the programming language. And you also must have this logic. So I repeat again one more time, guys. Learning the language is not that difficult. Understood, right? Guys, no, learning this language is not difficult. There are so many YouTubes, there are so many things already available. So this is, plenty of tutorials are available. But to know what to do, guys, to know what to do, it is in your hand. How many problems have you solved so far? That's it. It all depends on this. Yeah. How many problems have you solved so far? Guys, it 100%, the logic 100% depends on this. So if you have solved more problems, more the better. If you manage to solve more problems, that means, guys, your logic thinking also will be better. All right. So guys, so we have to search for problems, guys, and there's plenty of problems already available in the internet. So those who are doing IT, yeah, guys, those who are doing IT, and until now, if you are saying that, very difficult to do programming, and that's no, it's not really true, yeah. So you have not put enough effort. But if you put enough effort, guys, trust me, you can also do very good programming. That's okay, right? So all you need to do is, guys, after you learn the language, just go to internet. Okay, for example, guys, let's say we learn Python already, right? We learn Python already, right? So all you need to do is, guys, you have to go to internet, look for Python problems. Guys, look at this. They give you practice Python exercises, challenges, solutions. They got 280. Guys, no worries, guys. Tomorrow I will introduce you to eBox, and eBox has about 200 over problems also, right? But guys, these are extra, yeah, these are extra. I'm talking about extra. So by doing more problems like this, guys, eventually you will be able to build your own logic to solve that problem. Guys, now reverse the given number. Is this the only logic available? No, guys, definitely no. This is not the only logic. Guys, of course, people can come up with many, many logic. Somebody can say that, again, why not, instead of dividing it by 10, okay, I take this 98765, 98765, and divide it by 1000. Then, guys, what do I get? I get the quotient, yeah, quotient as, sorry, 10,000, yeah, 10,000, guys. The quotient will be 9, and then the remainder will be 8765. 8765. Guys, correct, right? So, guys, this is my quotient. Why we actually have to go and pull out the remainder? Why not we go on a quotient basis, guys? Can, right? And guys, now what you're supposed to do, you have to take this 8765 and divide it by 1000. Correct, right, guys? Divided by 1000. Then what do you get, guys? You get 8. Correct, right, guys? You actually get 8. 8 as the quotient. And the remainder will be 765. So what are we supposed to do, guys? The second number, you can always do this. You can take the second number, which is actually 8, and then you can multiply the 8 by 10. So you can multiply 8 by 10, and add 9. So guys, you get 89. You get 89. So guys, you see, this can be another logic. So definitely this is another logic. Yeah, this is another beautiful logic which you actually can use to solve the same problem. So which one is correct? Guys, both are right. As long as you are able to solve the problem mathematically, then both are correct, right? Both are actually correct. So there is no such thing that which one is better, which one. That's, yeah, of course, that's okay. But you are able to solve the problem. So guys, you're able to come up with the logic behind it, right? So to solve a problem, how many logic you have, guys? You can have infinite number of logic just to solve one problem. That's understood, right? Understood, right? So different people will have different idea to solve the problem. Not necessarily it has to follow this. Guys, look at this. You can also do like this, right? You actually can do like this. So 765. Sorry, yeah, guys, I put wrong number here. 765. So again, 765. You can take the 765 and then you can divide it by 100, right? 765. You can divide it by 100. Then guys, 700s are 700. So guys, you get 7 here. And then you get 65 as the reminder, right? 65 as a reminder, right? So you actually can multiply 89 with the 10 and you add 7. Sorry, guys, sorry. You take the 7, multiply by 100 and add 89 because you divide it by 100, right, guys? You actually can do something like this. You know, you actually can multiply. Earlier was 10, so you have to multiply by 100. So 7 multiply with 100 and then you add 89. So guys, you get 789. So this is another logic. Yeah, this is another logic. And guys, here also you can see the number is getting reversed. Yeah, the number is getting reversed. Initially it was 89, now 789. As if you continue doing it, you will get 5, 6, 7, 8, 9. You will definitely get 5, 6, 7, 8, 9. Yeah. So yeah, this is another logic. I believe now you guys got the idea of what do we mean by logic. Yeah. What do we mean by logic? So if you know what to do, then if you know how to do, then you actually can translate this into a program, right? So the moment you convert it into a program, then the computer can, so that means you can give a new number to the computer and you can ask the computer to solve that new problem. Okay. So we started our session with, how computer actually executing our statements. And then the next thing we saw is, how to become, how to write such programs. What is the skill set that we need to build? So we need to have these two skill sets. And I explain about the logic, logic. And I already give you some tips how to improve the logic. So you have to work on it. Yeah, you have to work on it. Okay, guys, I want to copy this and I want to paste it here. So what is this? Okay, guys, this is actually called Google Colab. And what I actually going to do is I'm actually going to do programming here. I'm actually going to develop Python program here. And I'm going to teach you guys how to do, I'm going to teach this language, the beautiful language called Python, right? Using this Google Colab, yeah? So what I actually going to do, I'm actually going to do programming here, and you can actually see my coding, from your PC, yeah? You can actually see my coding from your PC, yeah? From your PC. So hang on, give me a second. I will copy the second image also, and I will dump it in so that you can see the image, and then if you have any question, you can ask me later. All right. Okay, I'm going to share this in a link, yeah? So restricted, okay, copy link. So guys, this is your link. Please go to the link and see whether you can access my page, yeah? See whether you can access my page. Guys, the code is not real time, yeah? The code is not real time. So that means when I type the code, you won't be able to see it immediately, right? So you won't be able to see this immediately. You have to, every time you just need to click the refresh button, then the new code will start appearing. That's okay, right? The new code will start appearing. Okay. So now what are we actually going to do, guys? I'm going to give you guys introduction on Python. Yeah, that cannot access. Okay, it's restricted, no access. Okay, guys, hang on. Restricted. Oh, okay, guys. Anyone with this link? Sorry, yeah. Viewer, copy link. Done. Okay, guys. Let me paste it again. Guys, please try to click the link and see whether it's okay or not now. Fantastic. Okay. Okay. That's the introduction to Python. Yeah, introduction to Python. Okay. Do you guys remember, I don't know whether you guys remember this, guys, when we have babies at home, yeah, when we have babies at home, first, guys, what we try to, guys, we try to tell some to the babies, yeah, to the babies. And expect the baby to the word again. That's correct, right? So you will tell, shopping. Guys, baby will not say immediately shopping, yes, baby, but over the period, few times after you keep saying it, slowly the baby will start saying shopping, shopping. Guys, after some time, the baby will vocabulary, and then he will understand shopping a mall, right? Actually starts, so there are a lot of people there, and then a lot of fun things there. Then the next time when you ask the baby, where you want to go, then immediately the baby will say shopping. That the baby is not actually going to do shopping, but he knows shopping means something. Guys, understood, right? But guys, how did he actually get the word? Guys, we teach him, right? So guys, so similarly, let's say I have a robot in my house, and then guys, Sunday morning, yeah, Sunday morning, now I wake up and I see my robot is actually leaving my house. He's just walking out. He just opened the door and he's walking out, guys. Then I stop him and I ask him, where are you going? Guys, now I want the computer to say shopping. I want the robot to say shopping. That's correct, right? So if I want the robot to say shopping, then guys, I must tell him print shopping. Yes, understood, right? Of course, computer never go to school, so he cannot say it on his own. Suddenly one day, come up and because yes, you never train him. Also, guys, understand, right? You never train him. So this is the only way that you actually can train a computer, is by writing simple statements like this. So what you want the computer to say? You want the computer to say shopping. So guys, you write a simple statement, print, open bracket, close bracket. Guys, I will explain this later, yeah? But anyway, guys, look at this. And then in between, you put double quote, shopping, double quote. Guys, and when I run this, okay, guys, the computer says shopping. All right, guys, now the computer actually says shopping. Okay, the next question that I actually going to ask him is, okay, what are you going to buy? What are you planning to buy? Guys, now we want the computer to say television. We want the computer to say this. Guys, computer is not an independent body that it acts on its own. Suddenly he say, I want to go to cinema. Guys, no. Right? Unless you give him the instruction, computer will never say, I want to do this, I want to do that. So computer will say that only when you tell him to say it. So now I'm saying print television. So guys, it's printing television. Then guys, I want to ask him another question. Okay, how many you want to buy? And guys, I want the computer to say 10. And then guys, how much? Do you know the price? Do you know the price of a TV? Then guys, I want the computer to say 1,455.25 cents. Right? I want the computer to say this price because I know the price. I tell the computer already. So now the computer is telling me the price of the computer is 1,455.25. One last question, yeah? One last question. Do you know the shop has television? That the computer is supposed to say yes or no. In Python, we, to say yes, we have something called true to say yes, yeah? So for yes, we have something called true. For no, we have something called false. Right? We have something called false, guys. So when I run this, our friend says true. So that means, guys, the shop has television. Guys, I created few statements and I make the computer to answer my questions. I make the computer to answer my questions. So where are you going? Shopping. What are you planning to buy? Television. How many you want to buy? 10. Guys, any questions? Okay, so now, guys, I want to talk about literals. Guys, I want to talk about literals. Okay, any question, answer to any question falls into one of the four categories. So guys, number one, yeah, the number one is string. That's example, shopping, television. Guys, they are string. So that means, guys, what is string? Guys, a string is alphabets. You know, words or sentence or paragraph made using alphabets. So, you know, when I ask you, most of the time your answer is a word or sentence. And it is English alphabets, yeah, using English alphabets. Okay, LI. Next one is, guys, how many roti kosong you eat today, this morning? Two. Guys, okay, right? You know, how many coffee you had this whole day? Two or three. Guys, so numbers without decimals, we call them as integer. Numbers without decimals. And guys, examples 10, 20. Okay. And then what is the price of the computer? Remember, guys, just now, you know, we were talking about the price of the computer, right? Then, guys, your answer is in a float number with decimal. So, guys, your answer just now was, you know, just now was 145525. So that is actually a float literal. And one last question, guys. You know, I asked you whether the shop has television or not, guys, and you said yes or no, but you said it. So, guys, that is actually called Boolean. True or false. So, guys, any question, any answer to any question falls into one of these four categories. So it can be either string literals. As a literals means values, yeah, values. Right? Or integer literal or float literal or Boolean literal. Right? Okay. That's this is string literal is a special. That's the string literal is a bit special. And our friend is always enclosed with the double quote. String literals are special. They are always enclosed with double quote like this. with the double quote, yeah, with the double quote. All right, with the double quote. I don't put the bracket, then it's confusing. Okay, for example, shopping. So they are always with the double quote, yeah, they are always with the double quote. Whereas integer literals, integer, comma, float, comma, Boolean literals are not enclosed with double quote. So you just need to remember. So whenever you are referring to a string literal, quickly put a double quote. Yeah, it's okay, right? When while you're doing Python coding, yeah, while you are doing Python programming, if you come across any string literals, quickly, you put that inside, inside a double quote. As the number literals are Boolean literals, they do not require to be inside double quote, yeah. And guys, Boolean literal, yeah, Boolean literal has two values only. And they are true, comma, false. Yes, they are true, comma, false. That's, immediately your question is, true, false is also an English word. Why it is not enclosed with the double quote? Okay, guys. True, comma, false are registered as keywords in Python. So just these two words, not just these two words, yeah. So keywords are not enclosed with double quote. In Python, the keywords are not enclosed with the double quote. Okay. So now we understand the literals. Yeah, we understand the literals. So, yeah, we understand the literals. Okay, what is next? Okay, the next thing that we're going to talk about is built-in functions. So every programming language comes with its own keywords, and built-in functions. Every programming language, not just Python, yeah.
Hello?
Every programming language comes with its own keywords and also the built-in function, yeah. Okay. So print is one such built-in function. Okay, print is one such built-in function. or you can say print is an example for a built-in. Print is a built-in function. Guys, print is a built-in function. Okay. To call the built-in function, we use open bracket, close bracket. Immediately after the function name. Example, print open bracket, close bracket. Guys, so every programming language comes with its own keywords and built-in functions. Print is a built-in function. To call the built-in function, we use open bracket, close bracket immediately after the function name. So example, print open bracket, close bracket. Okay. In between the open bracket, close bracket, you can pass literals. Guys, you can pass literals. In this situation, the literals are called arguments. Guys, are in other words, guys, you can say literals between the round brackets. Literals between the round brackets are also called arguments. That's okay, right? So it is a literal, guys. It is actually literal. Shopping is a string literal, but it also has another meaning, guys, and another word, because we are passing this to a function. So in this case, it's good to, we can also say shopping is an argument to the print function. Okay. Now, guys, I want to give you an analogy. Yeah, guys, I want to give you an analogy. Okay. Do we have built-in function among humans? Guys, the answer is yes, we do have. Guys, for example, yeah. For example, let's say, guys, you are too busy. You are too busy. And you cannot go for lunch. Your friends, yeah, your friends, are leaving for lunch. Guys, now you request one of your friend to buy lunch. Hey, can you buy lunch for me, guys? Correct? You are requesting one of your friend. Hey, can you buy lunch for me, guys? So buy lunch. So buy lunch is an example for a built-in function among the humans. Just an example, yeah, just an example. Then, guys, what your friend asks, immediately your friend asks what you want me to buy. And then, guys, you reply nasi ayam Nescafe coffee. Guys, they are called literals. And in this case, since we are passing them to the buy lunch function, we can also call them as arguments. Guys, you said buy lunch, but guys, but your friend, go out of the office, take a lift, go to ground floor, take his car, drive to the restaurant, a restaurant, order food, collect food, and collect food. Order food, okay, collect food and pay bills. Finally, he comes back to office, give the food to you. For you guys, look at this. You just say buy lunch, but your friend, guys, so first he go out of the office, and then guys, he the took took the lift, go to ground floor, take his car, drive to the restaurant, order food, collect food, pay bill, that's not just that. Finally, he comes back to the office. He comes back to the office and guys, give the food to you. Did you tell him to do all these things? Yes, no, you never tell him to do all these things. But how come he actually go and do all these things? Because guys, the buy lunch means he has to do all these statements. Guys, he has to do all these steps. Yeah, buy lunch means technically he has to do, but you don't need to tell him, guys. You never tell him also, guys. Correct, right? You never tell him do this, do that. But your friend actually did this. So similarly, guys, similarly, in Python, we have a built-in function in Python. We have built-in function print, and it does many things and make the output appear in the monitor. That's okay, right? So that is what we call it as built-in function. Yeah, that is what we call it as built-in function. Guys, you can refresh the page. Yeah, please refresh the page. You already have the link. Please refresh the page. And then, guys, look at what I have typed in there and see whether you guys understand or not. Definitely you understand. But anyway, guys, now you should know what do we mean by built-in functions, right? What do we mean by built-in functions? So this is underline. Yes, similarly in Python, right? Similarly in Python, we have built-in function print, and it does many things and make the output appear in the monitor. You don't need to tell, go to this point, from here you start printing alphabet A, you actually don't need to do anything. You don't need to say anything. Just pass it. The print function will print it for you, guys. Okay, right? Will print it for you. All right. So guys, now we understand literals. We understand built-in function, and we understand how to call the built-in function. The built-in function is immediately followed by open bracket, close bracket. And in between the open bracket, close bracket, you can actually have arguments or literals. Yeah, literals. Okay, so there are 4 types of literals, guys. We already see that. And yeah, guys, we have done already. So we have learned literals. We already learned built-in function. Okay. Now, what are we going to do next? Okay, guys. I said it is actually a string literal, and this is actually now integer literal, and this is actually float literal, and then this is actually Boolean literal. So guys, now, okay, whatever that I said, guys, I want to know the data type. So we're going to focus. The next thing is data type of the literals. Right, guys, I already told you this is a string literal. I already told you that. Yeah, I already told you that. But anyway, guys, how can I know the data type of a literal? Guys, again, you can use a built-in function. Can use a built-in function called type. You can use a built-in function called type. Yeah, called type. So guys, look at this. You can say print. So what you actually can do, guys? Okay, so what you actually can, yeah. Any question? Yeah. Okay, guys, you can actually try this. Yeah, print. You can open bracket, close bracket, and guys, you can say type of shopping. Guys, you can say print type of shopping. Guys, it says string literal. Hey, what is this? Suddenly, you type something here, guys. Correct, right? So, guys, what we are doing, we are passing the literal shopping as an argument to a function called type. This type function returns the data type of the literal topic, right? And as we want to print the data type, so we pass the data type to the print function. As we are passing the literal shopping as an argument to the function called type. Okay, guys, this type function, this type function returns this type function. Actually, guys, this type function takes a single parameter. Right? It actually takes a single argument. We can say single argument. Right? It takes a single argument and returns data type of the literal shopping. Okay, I think I don't mention this, guys, because we already mentioned it in the previous line. Yeah. So the type function returns data type of the literal shopping. Guys, remember the analogy. Guys, remember the analogy. In the analogy, guys, in the buy lunch analogy, the last point was give the food to you. guys, and this is what I mean by written. Guys, understand, right? So you might get confused here. Okay, the type function returns the data type. Hey, what do you mean by return the data type? Guys, so this is the one, guys, in our analogy also, he returned the food to you so that you can eat. If he did not return the food, guys, we cannot eat. He go buy lunch already. But if he did not return the food to you, you cannot eat. So the entire steps go wasted already. Correct, right? He must give the food to you. So similarly, the type returns the data type, and we want to print the data type. So we pass the data type to the print function. Right? And the print function prints str. Guys, so similarly, guys, let's try some more. So print type of 10. Guys, one more, yeah, one more. So we are passing the literal 10 as an argument. We are passing the literal 10 as an argument to the function called type. The type function returns the data type of the literal 10. And we want to print, so we are passing it to the print function. So the print function prints it. Guys, look at this. So it returns int. All right. So string literal, remember, guys, I said, it falls into either one of the categories. So, guys, okay, I will just do 2 more lines here. Okay, the first one, I'm going to say 1455.55, and then true. Look at this. So, guys, this is a float, and this is Boolean. So, string, integer, float, and Boolean. String, integer, float, and Boolean. So we have four different types of literals, right? We have 4 different types of literals, right? And we saw the data type already. Yeah, we saw the data type because I was verbally saying, this is a string literal, this is integer literal. Guys, remember, I was verbally saying it. Now using the print function, we clearly see this is a string literal, this is integer literal, this is a float literal, and this is Boolean literal. So guys, now I want to do one more thing. Okay. Now, let us make the computer to calculate the total amount to be paid and tell us. Guys, let's make the computer to calculate the total amount to be paid and tell us. Guys, you can say print 10 multiply with 1455.55. Yes, it says 14,555.50 cents. Okay, right? So guys, he clearly said, 14,555, dot 50 cent. So that means, guys, you actually can pass a literal as an argument to the print function. You can pass an expression as an argument to the print function or equation, yeah, equation, yeah. So guys, summary, yeah, summary. you can pass literal as an argument to print function. And guys, one more thing, yeah, one more thing, guys, one more thing. Look at this. You can also pass, you can also pass more than one argument to the print function. Right, guys? So look at this. You can say print product colon comma television. You can pass more than one argument to the print function. Okay, and guys, the arguments are separated by comma. The arguments are separated by comma. Okay, and guys, look at this. You can also do this. Print quantity colon comma n. You can say print price colon comma 1455.55. Print is available colon comma, you can say true or false. Guys, you run this, you can see all these output here coming out beautifully. Right, I think I don't want to write the summary, guys. I think we know already, guys. Okay, right? We already know. So you can pass many things, guys. You also can pass print total amount to be paid, comma, and multiply with 1455.55. Guys, so when you run it, guys, you actually can see 14,555.50 cent. So 10,1455.55. True, guys, it's making a clear output. And guys, so now we know the print function, we know type function, we know true, false keywords. So these are certain things that we know from the programming language. And overall, we also learn what is a literal. Literals are enclosed, string literals, data types of the literals, and then string literals are enclosed with double quote. And guys, we have learned quite a lot of things today. Right, guys. So far, any questions? Yeah. Yeah. Go ahead. Go ahead, guys. All good. Okay. Fantastic. So, okay, guys. So the next thing, okay. So literals. Yeah, we covered a bit on literals already. So the next thing that we want to focus is called variables. Variables. So guys, now the baby grown up already. So the baby starts remembering the words, right? Yeah, so now what we want to do? We want to make our computer to remember the values, okay, and say it whenever we ask him. So we want the computer to remember the values. Yeah, we want the computer to remember the values and say it whenever we ask the computer. Right? How can we make the computer to remember? right? So guys, what we actually can do, we can assign literals to the variables and make the computer to remember. So guys, look at this here, look at this here. So you actually can say, look at this. You can say doing is equals to shopping. Product is equals to television. Okay, guys. So over here, doing, comma, product are called variables, right? We are assigning, we are assigning shopping. This is actually a literal to the variable. We are assigning. So here, doing, product are called variables. We are assigning shopping literal to the variable doing, right, guys? So, okay, and quantity is equals to 10. Price is equals to 1455.55. Is available is equals to true. Guys, okay, right? Is available is equals to true. So guys, we are assigning shopping, that's literal to the variable doing. We are assigning television, yes, and that is string, yeah. This is string literal. This is also string literal to the variable called product. Okay, guys. So we are assigning 10, that is actually integer literal, to the variable called quantity. Okay, and we are assigning 1455.55, that is a float literal to the variable price. And guys, finally, we are assigning true Boolean literal to the variable is available. So guys, the variable, right? The variable is again an alphabet, guys. So here, note, guys, variables are words without spaces, guys, without spaces. Variables are words without spaces. Remember, when we study literals, when we study literals, the words must be enclosed with double quote. Okay, now guys, why we actually have to enclose the literals with the double quote? Okay, guys, look at this. Variables are words without spaces, right? Guys, literals also, string literals are also words. That's correct, right? Television, look at this. I have television, which is also word without space. Product is also a word without space. Both also created using English alphabets. How do you actually differentiate? So now, guys, the question is, how do we differentiate? Guys, how do we differentiate? How do we differentiate variables from literals? Yeah, so look at this. Yeah, so here I have television. In this particular case, guys, in this particular case, product is a variable, television is a literal. But guys, there can be another case. So definitely there can be another case where we say television is equals to Sony. Thus, in this case, television is a variable, Sony is a literal. In this case, product is a variable, television is a literal. Right? Is a literal. However, guys, in this case, television is a variable, Sony is a literal. So how do we actually differentiate? In this case, product is a variable. In this case, guys. So remember here, when we study literals, the words must be enclosed with the double quote. So that means, whereas, guys, variables are not enclosed with double quote. And this is how you differentiate it. Remember, when we study literals, okay, we said the words must be words, study literals. I said, words must be enclosed with double quote. Guys, but when we study variables are not enclosed with the double quote. And guys, so this is how computer differentiate. Oh, this is variable and this is literal. However, in this case, television is a variable, Sony is a literal. So guys, so this is how he differentiates. So that is the reason why the literals are enclosed with the double quote. Right, guys? That's the reason, yeah, why variables, literals are enclosed with the double quote. Right? All right, yes. Guys, understood? Yeah, understood. Yes, double quote, yeah, double quote. So that is why, we use double quote. Okay, guys, variables are words without spaces. Yeah, you actually cannot have is space available. Then, guys, it becomes two words here. Right? Variable is supposed to be one word. But guys, literals can be two words. Right? Can be two words with the space. Because guys, I already told you, the literal can be a word, literal can be a sentence, literal can be a paragraph. right? Literal can be a corpus, huge. So as long as you cover the entire thing with a double quote, it's okay already. As understood, right? But when it comes to variables cannot have spaces. There are some limitations, declaring the variables. Okay, guys, we started the variables. Guys, we will explore the variables tomorrow. Yeah, we will go in depth with variables tomorrow. Yeah. But we started already. I gave you a simple introduction. Guys, you actually can read through all the things that I have done today. And then if you have any question, guys, we can discuss that tomorrow. Yeah, we can discuss that tomorrow. Right? Okay, guys. All right. Any other questions before we finish the session today? Okay, guys, if no other question, then thank you so much. I see you guys tomorrow. All right, guys, thank you.